Let's do this one. We're going to use the ratio test. And the limit, go ahead. Pardon? The limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n, I want this series to converge. Yeah, watch that. So I'm going to set that to be less than 1. And I'm going to solve. Okay? And no, I didn't expect you to do homework when I didn't give you the assignment sheet. So we need to be doing this now. We probably forgot some of this stuff between yesterday and today. So it's the limit as n goes to infinity. And then you're going to substitute in n plus 1. And now you have x's in there. And remember, there are 3 things that can happen. This will converge for all the x's, or just some of the x's, or one of them. So I'm putting in n plus 1. I know. Now this is 3 to the what? What's that going to be? 3 to the what? n plus 1 plus 1, so it's n plus 2. Guys, yeah, you should all have your paper out. You should be trying this. That would include Kevin. This might work. There. I don't know why it does that. Okay. Matt, now what am I going to multiply by? Yeah. Okay, so it's 3 to the n plus 1. Now, if you're good, you guys, if you're good with just subtracting exponents, I'm fine with that. I just do it this way because it's most of you prefer it. Okay. I'm just going to cut that. Okay, so let's go ahead and simplify that. And as it gets more complicated, and some do get more complicated. Okay, so you have n plus 1. Oh, I wrote something wrong. Wait. Oh, no, I didn't. Okay, so well, I like to rearrange it. N plus 1 over n. So I don't lose anything. X plus 2 to the n plus 1 is x plus 2 to the n times x plus 2. And that's going to be over x plus 2 to the n, because it's just easier to see it. You don't have to. You can cancel all with that. I'm fine. This is 3 to the n times 3. This is 3 to the n times 3 squared. If I do something that you don't understand, or I make a mistake, let me know.
Do we have like a homework sheet for like 8.5?
I'll get you started on the next problem, and I'll run down and grab it. Yes. How did I what? I just rearranged things. So I did the n plus 1, right here, in the n's. And then I did the x plus 2. That's x plus 2 to the n over x plus 2. And this was just x plus 2 to the n. So I got these rearranged, and then I rearranged the 3's to be vertical. So 3 to the n times 3 and 3 to the n times 3 squared. Are there questions on these exponents? I just rearranged it. I'm not sure what the question is. And actually, it turns out to be really one of your favorite sections in this chapter.
Everything crosses out, right?
Almost everything. That goes. That goes. When you have the negative signs, as we did yesterday, it's a little trickier. What's this limit going to be? 1. These cancel out. And then I still have n plus 1 over n, but I can find that limit. That's 1. And I'm still left with an x plus 2. I'm still left with a 3 over 3 squared, which I should have reduced. But anyway, and I have this in absolute value. Okay. And so let's see. I'm going to get x plus absolute value of x plus 2 over 3 is less than 1. I'm not done with that yet. What do I have to do with the 3? Multiply it. It has to be 1x. Right now you have a third of an x. So it's x plus 2 is less than 3. What's the radius of convergence? Radius is equal to 3. So what this means is if I have my little line here, and this is centered at where? -2. And so I'm going to go 3 units to the right, which is going to be where? 1, and 3 units to the left. -5. I can do it algebraically. That's the geometric interpretation, which actually has probably more meaning than for you to go, well, x plus 2. Depends on how you like to look at things. And then I subtract 2 from all the parts. So -5 is less than x is less than 1. Now, on the exam, you get 1 point for knowing that you're going to use the ratio test. And I do that when I set up my ratios here. Right there. When I do that, I've got my point. Then I get another point for finding, probably for getting to this point right here. It's like 6 points. You know, another point for finding the 1 and the -5, and you're going to lose points if you don't do what? Check the end point. Because when I put -5 and 1 into the ratio test, we talked about this yesterday, it's equal to 1. So you got to put it back into this. So should we do the 1 first? So when x is equal to 1, and see what happens if you think about it. Okay, guys. This is 3 to the n times 3. So this will cancel, right? This is equal to the summation of n over 3. Well, that's pretty easy. Does that converge or diverge? Diverges. Okay? And now I want to do the -5. So x equals -5, the summation of n, and it's -3 to the n. Oh, sorry. No, that's right. -5 plus 2 is -3. And then this is 3 to the n times 3. I didn't leave myself any space. Do you guys know what's going to happen when I divide these out? It's -1 to the n. I'm going to get summation -1 to the n over 3. And then I have an n. Does that converge or diverge? It's alternating, but does the limit of this sequence go to 0? Diverges. So that's it. The interval of convergence is between -5 and 1. I would include the 1 if it works. Sometimes they work, sometimes they don't. So it's not too bad. And the assignment is not too bad. We have 3 days. Usually, once you get into this, you like doing them. That's the assignment out of this section. The next section, 8-6, is critical because it's going to be several multiple choice questions on the exam. Okay, I am going to bring up, maybe. You have a day 2. Yes? The interval is the endpoints between 1 and 2 or something. The radius is how far from that center point are you. That's why they call it a radius. Whoa, 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 whoa. Is that it? Hey guys, here's another problem. Okay? One more problem and then you have work time. And then tomorrow, I don't know. I think I have a worksheet, but I gotta pull it. And you have work time. I want, you know, if you're okay. Okay. This could converge just at a point, like 0, or it could converge over an interval, with or without the endpoints, or it might converge everywhere. I don't know. So this is And don't forget to watch out for E when it gets hidden in there on those limits. Okay. Okay, so this is x to the n times x over x to the n, and then it's the cube root of n over the cube root of n plus 1. And you're going to see a lot of times, you'll see this, the n over n plus 1, and it's going to be 1. Just be careful, because what if I had this? N plus 1 over n, but it's to the nth power. That limit is e. So you just got to just be careful, that's all. So this is going to go to 1, and these are going to go, and the absolute value of x is less than 1. Centered at the origin. So what's x between? And then we have to check our endpoints. Because you're only going to get about 3 points of the problem here. And I believe, okay, because I haven't graded these, but if, let's say you get your interval of convergence wrong, but the fact that you do try to test your endpoints, you still get that point. So you could get 1 point for doing the ratio test, 0 for this, but 1 more point for trying the endpoints. So it's worth it. So we're going to put in, let's try x equal to 1. And so it was the summation, negative 1 to the n times 1 to the n over the cube root of n plus 1, right? Now you use your convergence test. Oh, is it? I've got it mixed up with the other one. Get it mixed up with the other one. Okay. Well, we know this. Oh. Okay, and that's still okay because it's really this. N equals 1 to infinity. It's negative 1 to the n, and if you want to think of this as n to the 1/3, it's an alternating series. Remember, 1 over the cube root of n is certainly decreasing, and its limit is equal to 0. Okay, so now we'll do x equal to negative 1. That's definitely decreasing. That converges. It's an alternating series. Alternating series. Pardon? Still can't hear you. He was talking. You just say alternating series test converges. All you do is look at this. Were they there? Oh. No, it's alternating series. Question.
Yeah, we're not the peanut. I was it would diverge when just one the n over n it would diverge because of P series.
But this is alternating series, yeah. Yeah, because it's jumping back and forth. It's making it go to 0 faster because of these are negatives. You're adding, but you're also taking away. So it goes to 0 faster. 1 over n doesn't go fast enough. Yes. Hey, you guys? Matt? Go to the table behind you, please. Had enough.
It took 5 months.
3. I don't care. Okay, let's do the other one. X is equal to negative 1. What happens here? Justin? What happens there? Yeah, these, you guys, girls, did you get this? This is just 1. So then I get this. I have to finish the problem. Yes. That's just 1 to the n, so it's 1 over the cube root of n. Had it been 1 over n squared, it would have converged, but it doesn't. It diverges. P series. So the answer is, the radius is what? That's this. That's 1. And the interval, let's see, -1 didn't work, right? But 1 did. And that's your answer. Okay, you should have your books out. It's 1 through 5 and 7.
And 9.
Odd. Yeah. They did not have this on the free response last year. I think it's a good chance it'll be on the free response
I
this
think it
year.
would be a good one for me to win some points.
Absolutely. Honestly, the statistics on this this chapter 8 questions that are on the exam. Okay, you guys. Shh. On the free response, that's to do with the Taylor polynomials and this information. The average is like, last year it was high, it was like 4.5. But usually it's like 2 or 3. We can beat that. No, score of 2, 3.
Like some of the problems we were doing them last year, like how some people did so bad and get like 1 point down to the national.
Vader, big game tomorrow night?
Because I'll have students that'll only get 1.
Just racial jokes are beautiful.
Okay, there's more people who could be split up. So we need to work. I know. Good. Try an assignment. Now that you have, oh, you don't need to.
We got him.
Okay, you guys have half hour. Oh,